Welcome to this new tutorial video where we will be taking our Web3 app to the Solana Mainnet by creating a configuration for our app. In the process of developing programs or smart contracts, all blockchains have test networks that serve to develop without risks and without the inherent costs of the main networks. In the Solana blockchain, there are two test networks known as Devnet and Testnet, where for both you can request test tokens to make transactions, with Testnet being a replica of the main network or mainnet that is used to test our programs or smart contracts under very similar conditions to how they would work on the main network. And Devnet offers a more flexible and configurable environment for the bulk of our tests during the development process. In our previous tutorials, we have developed an app that allows you to log in with a seed phrase or create a new account on the Solana network, and once inside, you can see your wallet address, your account balance, and the NFTs you own. You can also create NFTs from an image file directly from your phone using the QuickNode IPFS service. So far, this whole process, we have done it in the Solana DevNet. Today, we will be adding the ability to connect with the main network or mainnet by creating a configuration page in our app. We go to the repo of our app from the previous tutorial, link in the description, and we are going to copy the address as shown on screen, and in a folder of our preference from Visual Studio Code, we do git clone with the address of the repo. Let's create a file in the pages folder called config.dart, and inside we will create a stateful widget called config page, which for the moment will consist of a scaffold with the title Network Configuration. Now in our main.dart file, we will create the route to navigate to this new page. We will copy the home route and change the name of the route to config, and this will return the config page that we have created. Remember that if config.dart is not imported automatically, you must do it manually. In our home.dart file, we will add inside the app bar, in the actions parameter, this button icon to navigate to our configuration page. Back in our config.dart file, we will create this enum to define the two networks we will work with in the following way. And we will declare all these variables. A network variable that we initialize with the mainnet option, an instance of Flutter storage to read and write to storage, 2 text editing controllers to receive the RPC addresses that the user wants to configure, and these 2 strings mainnet RPC and devnet RPC to manipulate the data that we will read from the internal storage. For the body of our scaffold, we will create a column that will first display a switch list tile with the text use devnet. Our switch will be active when the network is devnet. And when changing the switch, we will change the value of network as follows. In this way, with this switch, we establish the value of our network variable. Now we will place these 2 text fields, devnet RPC URL and mainnet RPC URL, which will be enabled depending on the network selected in the switch through the enabled parameter. Finally, we will place this list tile with a right arrow icon and the text accept. And here, we will start the process of validating the information entered by the user. Before that, we need to know the RPC data stored in the phone's memory. For that, in init state, we will call a function read RPC. This function will read the network, devnet RPC, and mainnet RPC keys from the phone's storage, if they exist, and will save them in the variables shown on screen. Remember that devnet RPC and mainnet RPC have already been declared and can receive null values. Then we will update the text of our text fields if valid RPC addresses have been found in storage, using setState to update the UI. If it has found the devnet value in storage for the network key, we will change our network variable to devnet via a setState so that our useDevnet switch activates accordingly. For the onTap function of our list tile, the first thing we will do is check if there was any change in the RPC configuration. We consider each case separately, if the network is in mainnet or if it is in devnet. For each case, we check if the address in the respective text controllers is the same as the one we read from internal storage. We only save the selected network in storage and return to home. If a new RPC has been entered, we will validate it through a function that we will call validateRPC, to which we will send the text present in the text field according to the selected network. This function will return a bool that we will store in this valid variable. The validateRPC function will start by creating a version of the received RPC with the WSS prefix instead of HTTPS, and with both addresses. It will create a Solana client as follows. Then we will do a try catch, which will return false if any error is found, and we will use the client we created to access the getHealth and getGenesis hash methods. The first method will return a string, okay, if the RPC worked correctly, and otherwise will return an error. The getGenesis hash method will return the Genesis block hash of the chain the RPC is working with, and we will use it to verify that an RPC from a network that does not correspond to the selected one is not placed. If the health received is okay, we will continue with the verification. Otherwise, the function will return false. The verification will depend on the network, and according to the case, we will call a verify hash function that we will now create using the standard RPC of the Solana network for each network and the hash we obtained earlier. The verify hash function will simply create, as we did before, a WSS prefixed version of the RPC it receives and will create a Solana client for which it will request the Genesis block hash and compare it to the hash received for the RPC entered by the user. If they match, it will return true, and otherwise it will return false. This way, we make sure that the entered RPC works on the selected network. It only remains for us to write the information in storage if the hash was verified correctly, depending on the case, or return false if the verification was not successful. After knowing the validation result of the RPC, we will call this function validateRPC_dialog, which will display an alert dialog to inform the result on screen. The function will receive the context and the Boolean result of the validation and will display the text, "The RPC has been successfully updated." If the valid parameter comes in true, and otherwise, it will show the message, "The entered RPC is not valid for the selected network." The alert box has in its actions parameter an OK text button that will call the read RPC function to reload the content saved in storage and close the alert box. All this in case an invalid RPC was entered. And having entered a valid RPC, will navigate with the new configuration ready to the home route. To finish our app, we will modify the initialize client function in our home file, where we will remove access to the .env file, and instead we will create this RPC URL variable and read from storage the network key. If a valid key is not found, we will work with the standard Solana RPC temporarily, and we will write the network key to mainnet and the mainnet RPC key with the temporary RPC. Remember that this RPC has many limitations, and it will be necessary to update it according to our needs. For the cases where the network variable obtained the mainnet or devnet reading, we will proceed to read the respective RPCs saved in storage, with which we will create our Solana client to interact with the corresponding network. We update the code to create our Solana client, as shown on screen, and our app is now ready for testing. A couple of details that are escaping us are update the way we take the RPC in our NFT API.dart file. Remember that the RPC will now be taken from internal storage, depending on the network saved in the network key. And we must also create our .env file, but for now, we will only need the QuickNode API URL IPFS variable with your API key from the QuickNode IPFS service. When running our application, we navigate from home to the configuration page. We see how it shows us the default RPC on the Solana mainnet. Let's activate DevNet mode and paste our DevNet RPC from QuickNode. When returning to the configuration, we see how our DevNet mode remains activated. If we change the DevNet RPC to the mainnet standard RPC, the dialog box shows us that the entered RPC does not work for the selected network. And when returning, it returns to the default values. Let's enter a QuickNode RPC for mainnet. And in our home root, we see the new balance of our account for the Solana mainnet. Remember, if you want to mint your NFT in mainnet, it is necessary that you deploy your Solana program also in the Solana mainnet. If you made it this far, your app is getting incredible, and your users can use both mainnet and devnet. If you have any questions or ideas, leave them in the comments. Subscribe for more. Until next time.